Okay, boys, we're going to be looking at problem solving with trigonometry and bearings. Now, these are the steps we're going to follow. So let's keep this in mind when we're solving the questions. All right, so we're going to draw a diagram, label the diagram, form a right angle triangle, and then if we have to find a distance, we're going to use Pythagoras' theorem or SOHCAHTOA. And to find an angle, we're going to use alternate angles or the inverse sine, cosine, and tan functions. So let's do our first question. All right, here's our first question. So it says, from a camp, a hiker walks due north for 8 kilometers, then 6 kilometers due west to a lake. So let's draw that first. So they walk north for 8 kilometers. Let's just say that's 8. And then from there, they walk 6 kilometers due west, which is, say, in this direction. Okay, so that's all good. And I'm going to form a right angle triangle now. There we go. And then I'm going to label the diagram. So just following those steps on the previous page. So what can I label on this? Well, north for 8 kilometers. Okay, so that means this distance here is 8 kilometers. And then due west for 6 kilometers. So this is 6 kilometers. Right, and we can put in a right angle triangle because in the list of steps it says form a right angle triangle. Okay, so I've labeled the diagram. I could even say this is the camp. So I could put a little C for camp, and he walks to the lake. So I could put L for lake, if you like. Right, so that's all labelled, and let's look at answering the question now. It says, how far is the hiker from the camp? Well, the hiker's at the lake now, and the camp is over here. So the distance we've got to find here is x. All right. Now it says use SOHCAHTOA or Pythagoras' theorem to find the length of a side. So if you go back to the beginning, it says to find a distance, use Pythagoras' theorem or the trigonometric ratio, sine, cos, or tan. Well, we've got two sides, and we have to find the third side. So that means we're going to use Pythagoras' theorem. So if you remember, Pythagoras' theorem is a squared plus b squared equals c squared. And let's just change the color momentarily. So longer side, the hypotenuse is C. The other two sides are A and B. Okay, so we're going to have 6 squared plus 8 squared is equal to x squared. 6 squared plus 8 squared on your calculator should be 100. And then square root both sides, you'll get 10 kilometers is x. Okay, so we did part A. So part A of the question all done. The part B says, what is the bearing of the camp from the lake? And because the bearing is taken from the lake, you have to draw a compass in at the lake. So let's just do that. Try and get the line straight enough. All right, so let's draw that in. There's my line. Just move that across a little bit. Now, the lake is due west, so when I draw my compass in, that line should be right on top of the 6 kilometers. Okay, so I'm just going to adjust that. So there we go. All right, so there's my compass. And don't forget the lake was due west. So this is the westerly direction over here. This is north, obviously, and this is south, and then this is east. Okay, it says find the bearing or the direction of the camp from the lake. Now it's from the lake, so this is the direction here you've got to find. So starting from here, so the person is here if you like. There's your person, little stick figure. Okay, and you've got to find that direction. Now that means I need to find this angle in here. If I'm going to do the compass bearings, that angle there. To get that angle there, I need to know this angle here. Okay. So how do we work out that theta? Well, we've got two sides, the 6 and the 8 there. And if I'm thinking back to trigonometry, so this is now finding an angle. So for trigonometry, I'm just going to label this side. This is the opposite side to theta, and this is the adjacent side to theta. So that means I'm using tan. So for part B, which I'll put down here, I can now write down what tan theta is equal to. You know, tan theta is equal to opposite over adjacent. Opposite over adjacent is 8 over 6. Okay, and then I'm going to use the inverse tan feature, tan minus 1, 8 over 6. All right, or 8 over 6, or 8 divided by 6. 8 over 6, close bracket, and equals, so do that on your calculator. Shift tan 8 over 6, close bracket. Should get 53 degrees to the nearest degree. Okay, so we'll put down approximately 53 degrees to the nearest degree. Okay, so that's 53 degrees in there. Now, if I can get this angle, then I can do my bearing. So we know that this angle here is 90. So if theta is 53 degrees, so take away from 90. So I'm going to say 90 degrees, take away 53 degrees is equal to 37 degrees. Okay, so therefore the bearing so that means this angle here is 37 degrees. So the bearing will be south 37 degrees east. Okay, now if you wanted to use a 3-figure bearing, then you'd have to do the clockwise angle from north as an alternative answer, of course. So the angle that you would need to get the 3-figure bearing, right, is this angle here. Now we know north is 0 degrees. We know that east, so east is out here somewhere. That's 90 degrees. So if theta is 53, we know that up to there, that's a 90-degree angle. 90 plus 53 is 143. So the other way you could write the bearing, okay, so first of all, this is full marks here, or you could go 90 plus 53 degrees equals 143 degrees. That's the other way you could write that bearing. Okay, so write that down, and then let's have a look at question 2. Okay, so you can pause the video if you want and have a go at this question. Have a go at drawing the diagram. So you've got a plane leaves an airport and flies 600 kilometers on a bearing of 145 degrees. Right, first thing to do here is to draw a compass so we can show that bearing, that angle. So there's my compass. And we've got a bearing of 145 degrees. Okay, now 145 degrees will be out here somewhere. All right, so let's see why that is. All right, you've got north at the top, which is 0 degrees. You've got east, which is 90 degrees. You've got south, which is 180 degrees. Okay, so this angle here is your 145 degree angle, right? And the plane leaves the airport, if you like, so we can call this point A, and we'll call this point here P for plane, right? And it flies 600 kilometers in that direction. So we can label that side, if you like, 600 kilometers. So let's put that on the side there. So 600 kilometers in that direction. All right, so this is the direction that the plane is flowing. Okay. Now, actually, let me just put the 600 kilometers on the other side. It'll give me a bit more room when I finish the question off. Okay, so let's put 600 kilometers here. Okay, all right. Now the question says, how far south of the airport is the plane? So we've got to look at the southerly direction, right? The southerly direction is here. So it's from the airport, we've got to calculate the southerly distance. So what you're going to do is look at the distance in the southerly direction, which is this distance here. I'm just going to draw it through there. I'm going to complete my right angle triangle, because in all these questions you have to form a right angle triangle. There's your right angle. So the distance they want you to find is this distance here, x. And x goes from the airport to the corner of the right angle triangle. That's your southerly distance, your distance in the southerly direction. Now, we don't have enough information to use Pythagoras' theorem because you need 2 of the lengths of the triangle, but we can use trigonometry. So now it's 145 degrees up to there, and it's 180 all the way down to here. So this must be 35 degrees because those 2 angles mess that up to the 180. Okay, so if you think about it, up to there is 180 degrees. So it's going to be 35. So now we've got the right information to work out the length of the side. So this is my angle here. This is my hypotenuse, and this is my adjacent side. So that means I'm using cosine. So I'm going to write down cos theta equals adjacent divided by hypotenuse. And then I've got cosine 35 degrees equals, now the adjacent side is x, and then the hypotenuse is 600. Okay, so all you've got to do now is get the x by itself, and you've got your answer. So we're going to multiply both sides by the 600. Okay, that cancels with that. And you're left with x equals 600 cos 35 degrees. Okay, so put that into your calculator. 600 times cos 35 should get 491 kilometers. Yep. So you go x to the nearest kilometer, so approximating 491 kilometers. There we go. Now, part B says, what is the 3-figure bearing? So that's part A. What is the 3-figure bearing of the airport from the plane? Now, because the bearing is taken from the plane, so this from the plane, That means you have to draw your compass in, a second compass in at the plane. So P for plane. So you're going to draw this in here. There's the plane. And this line there should be in line with the right angled triangle. There we go. That's north. Okay. Now, think back to alternate angles. Remember, alternate angles are like a Z shape, aren't they? Okay, so I'm just going to trace around to create a Z shape here. So tracing around that angle and then getting that Z shape. So my alternate angle is going to be right inside, isn't it? So let me just change thickness. We go thin. So this angle in here is 35. 35 degrees. There we go. So that's my bearing. So think that you're at the plane now and you've got to describe the direction to the airport from the plane. So it's going to be north, 35 degrees, and this is obviously the westerly direction. So if this is part A, part B, it's north, 35 degrees west, or you could do the three figure bearing. You could take 360 away from that 35 and you get 325 degrees. Okay, so copy that down. Now pause the video and try the question 3 by yourself. Okay, so we've got question 3A here, so try this one. There's the answer, which is B. What is the bearing of the starting point from where she stops? And then you're going to also pause the video after question 4. Okay. So let's, all right, so hopefully you've had a go at the question now. And we're going to, she cycles due south. All right, so due south means you're starting here and going down. All right, that's due south. And then from there, due west. Okay, so there we go. There's due west. Yep. Then we're going to complete that little right angle triangle. Okay. Now we've got to label the diagram. So we know that 10 kilometers is due south. So she basically started at the top here. Okay, so just here. And this is 10 kilometers in the southerly direction. This is your right angle triangle. And then 7 kilometers due west. Right, this is where she ends up from the cycling route. So she starts at A, she finishes at B. Right, just so we can use some letters there. That says, how far is Jana from her starting point? Well, she started at A, finished at B, so this is the distance we've got to calculate. And we're going to use Pythagoras' theorem here because we have two sides of the right angle triangle. Okay. And this side will be C. These two sides will be the A and the B there. So you're going to have 10 squared plus 7 squared is equal to x squared. All right, now if we add that in there, 10 squared plus 7 squared, 149. Take the square root of both sides to the nearest kilometre. You're going to get 12 kilometres. So x is approximately, so to the nearest whole number, you should get 12.2 on the calculator, but to the nearest kilometre, 12 kilometres there. Okay. All right. Now, what is the bearing of the starting point from where she stops? Now, she stops at B. Now, because the bearing is taken from where she stops, so from where she stops, that means you've got to take the bearing from that point there. So You have to draw your compass in at B. Yep. And then there we go. So about right. There we go. All right. So you got to put that in line. Here we go. That's rough. A bit rough there. That should be perfectly in line actually. So I might just delete that and try again. So I want to get this exactly in line with the horizontal side of the triangle. There we go. That'll do. Close enough. All right, so we've got north here. North up top. There we go, north. And we've got to find the bearing of the starting point from where she stops. She stops here, so we've got to find this direction here. This is where she stops, just here. Okay, so that's the direction. We need this angle here, right? Now to get that angle, we first need to find that angle. Okay, the angle inside the triangle. So let's do that. Now what's the opposite side? Here's the opposite side. Here is the adjacent side, right? I'm not going to use the hypotenuse because the hypotenuse is an approximation for the length. It's not the exact length, whereas I know that 10 and 7 are exact. So I'm going to use tan. So tan theta is opposite divided by adjacent, which equals 10 over 7. Okay. And that means theta is the inverse tan of 10 over 7, which equals, okay, let's go shift tan 10 over 7. That's 55 degrees. Okay, 55 degrees there. Now that's not the bearing, right? The bearing, which I'll write over here, is equal to, now this is 55 degrees here, approximately to the nearest degree. Okay. We need to know this angle in here. Now this angle must be 35 degrees approximately to the nearest degree. So the bearing will be north, 35 degrees, and this is the easterly direction, isn't it? East. Or if you want to do the 3-figure bearing, it's just going to be 0, 3, 5 degrees. Okay. All right. So copy that down if you didn't get it correct. And let's try question 4. So I want you to try question 4 on your own. Pause the video. Here are the answers so you can self-check. Okay, so let's have a look at the first part. Triathlete cycles 20 kilometers from the end of the swim leg on a bearing of 200 degrees. Okay, so let's draw. Actually, I'll draw a straight line there. I'll get rid of that one for a minute. Okay, let's draw a nice straight line. So I'm going to draw my compass in. Here we go, so I can get my bearing. Okay, all right. So there's my compass. Let's draw, label the diagram here. We're going to have north up the top, obviously, east, south, and west. Okay, now remember the angles with 0 degrees up the top. East is 90 degrees, or 090 degrees. South is 180 degrees. And west is 270 degrees. Now, the bearing that we've got is 200 degrees. All right, so 200 degrees will be somewhere in this direction. So it's between 180, it's probably closer to 180 obviously than 270. So out here somewhere. All right, so we'll mark in that 200 degree angle. Now it's got to be clockwise from north, remember? So the clockwise angle from north is this angle here, which is, we'll label that 200 degrees. Now up to south is 180, so in here must be 20. I'm going to put that in there, that's 20 degrees. Okay, so now we've got the start and the finish, if you like. So starting at A, finishing at B. There we go. And how far to the nearest kilometre has the triathlete travelled in a now it's a southerly direction, isn't it? So because it's a southerly direction, that means you want to work out the southerly distance. Okay, so let's do that. The southerly distance. Let's change the thickness here. Right, so the southerly distance is this distance here. I'll start from here. So coming down here is the southerly distance. Okay, and then just completing my right angle triangle, so drawing a horizontal line from here to here. It keeps on snapping into place, which I don't want. So I'll have to draw that by hand. That's okay. All right. So let's draw that southerly distance in. So southerly is going from here. Sorry, not southerly. The horizontal line is meant to be going from here. All right, there's my horizontal line. Okay. This little bit on the end I don't need. So the southerly distance is from there to there. It's a vertical distance. Okay. All right. So what is the distance, the southerly distance? Do we have enough information? We do. I haven't labelled because it says a triathlete cycles 20 kilometres from the end of the swim leg. Okay, so 20 kilometres is the distance that they've travelled on a bearing of 200 degrees. So we've got to put that 20 kilometres in the right spot. So that's where 20 kilometres is. I've already got this angle here, 20 degrees. So we can use trigonometry now, can't we? This is a hypotenuse. Now, the x side there is the adjacent side. Okay, so we'll call that adjacent. Right? I didn't put A because I've already got an A there. So adjacent. So that means we're going to be looking at cosine again. So if you look at it, cosine of theta is adjacent divided by hypotenuse. Okay, so adjacent divided by hypotenuse, that means we're going to have cosine of 20, right, because we've got to use the acute angle. Adjacent is x, and then hypotenuse is 20, right? Then you've got to get the x by itself, so we're going to multiply by 20 on both sides. All right, cross that off, and you're going to get x is equal to, now it's 20 times cosine of 20, which is 18.8 kilometres. Which is, okay, so 18.8, which to the nearest kilometre is 19. Okay, so let's just change that. So approximately 19 kilometres. You get 18.8, but to the nearest kilometre, 19. So approximation symbols there. So 19 kilometres, right, which is done. So the southerly distance, x, is 19 kilometres. Now, what is the bearing of the end of the swim leg from the finish line? Now, it's from the finish line. The finish line obviously is at B. So you're going to have to draw a second compass in at B, right, because that's where the bearing's being taken from. Maybe we should change colours there, make it a bit clearer. Okay, so let's do that. There we go. All right, so draw your second compass in. Now that second compass should be in line with the horizontal side of the triangle there. All right. Now, make sure you're aware of where the parallel lines are. Okay, so there's your north arrow, and that's parallel to the other north. Now this is 20 degrees in here, which means the other alternate angle must be 20 degrees in here. You're describing this direction there. You're standing, if you like, at point B. So the direction or the bearing is going to be 0 to 0 degrees, or north 20 degrees east. Okay. All right, so that's it. Make sure that's copied down if you didn't get it correct.